All right, didn't get any requests. Didn't get a request this morning for any questions to be answered. So I've got the chat open on the left side of my screen. So you got questions, feel free to answer them. I'm just responding to a few messages right now, and yeah, just ask your questions as you get them. Can we go over problems 6, 23, 24, and 54 in the homework for Orgo 2? All right, let me bring that up. Almost there. Question 6. 6-ethanol may be prepared using 1-bromobutane along with simple organic reagents. Solve the compounds to complete the following reactions used to synthesize 2-hexanol. So the first one, you've got this 1-bromobutane, and you're asked to figure out to draw the product. So this is going to be a simple insertion. Now, the question with this is going to be, how hard is it going to be to insert the magnesium bromide? So I'm wondering if any issues you're having for the first part are simply formatting. Let's see what happens if I just write MGBR. So if you just draw the structure, and on this particular atom you alter it as text and just make it MGBR, that'll be the correct answer for that one. All right, next one. We have MGBR, and we want to add something that if we acidify it will give us this product here. So let me draw it out. Well, something acidified gives us, how are you drawing it? 1, 2, 3, 4, 5, 6. Oh, one too many over. So these are going to be good for attacking carbonyls. So if we look at our starting compound here, 1, 2, 3, 4, 1, 2, 3, 4, this is a carbon coupling reaction. So our break's going to be there. So this is whatever our starting compound was. And the only thing that's going to attack something like that would give us a structure would be what's called ethanal. This compound here. So your MGBR, the cation, is going to attack here. We'll get a break up there. And then the hydrogen is going to acidify it to give us the alcohol. So if I draw that structure, so that's correct. So that's how you do number 6. I think a lot of the issues I would think you would be having for the part one is just getting the MGBR grown in there. In terms of this, keep in mind Grignards are carbon coupling reactions. So in terms of how we made the final product, we look at our starting carbon, our starting chain. Anything else that remains was probably a ketone. Can't see the second part with the glare. Let's see which one's creating the glare. A little bit easier. So that's the second part. If we take our starting butane, cut it off, that's what we had to attack. Right, problem 23. Sometimes the strongly basic properties of Grignard reagents can also be turned to synthetic advantage. Chemists need samples of butane, needed samples of butane specifically labeled with deuterium, carbon D, or hydrogen D, the mass 2 isotope of hydrogen shown below. So we've got this compound here. So complete the following reactions to show the preparation using deuterated water, D2O, as a source of deuterium, butanol, and the necessary organic reagents. So you're starting with 4 carbons. And you've got an OH. And you ultimately want to make this brominated complex here. Now this is a primary alcohol. We can do this through some type of substitution. The big thing here is we don't want to go through a carbocation intermediate. If we go through a carbocation intermediate, we run the real chance of getting rearrangement. So it gives you a few options here. The first one is sulfuric acid followed by bromine. This is dehydration. You wouldn't do this because the Br2, basically the first reagent, H2SO4 followed by Br2, would actually give you, if you're lucky, this complex, more than likely this complex. The next one, Br2, doesn't have any Fic. Magnesium, methyl magnesium bromide, CH3Br. It's going to deprotonate. Because this is such a good base, it's just going to deprotonate the alcohol. You're not going to get any reaction. Your HBr or PBr3. So the PBr3 here is a viable option. So PBr3 does not go through a carbocation intermediate. It's going to be really good about, in fact, this is why we use it, is that it's actually a stereoselective reagent. So my guess here is going to be HBr or PBr3. And if I check my work, it says I'm correct. So the next step, we've got this complex, and we want to know what happens when we do the Mg. Well, when we add the Mg, we just get the Grignard reagent. So the same as before. Now it says, what happens when you react this with deuterium? Well, the best way to draw this is actually this way. And we'll get rid of the MGBR to make it more obvious. You have a carbanion here. This is going to attack the deuterium, and this will leave you with what you want, which is the deuterated butane and MGBr hydroxide. So that's the process for question 23. Question 24. Select the single best answer. What combination of aryl halides 1 through 3 and alkene 2 through 6 is the best choice to prepare the compound by a Heck reaction? So I did update the notes on this. There was kind of missing a lot of details. Luckily, I found something better than your book. Oh yeah, the deuterated ones, like, it's a lot of work for, in my opinion, a pretty trivial result, but whatever. They're trying to make Grignards look important. Okay, so Heck reaction is actually pretty straightforward. So what we're looking with a Heck reaction is that we need some unsaturated, so an unsaturated R group attached to a bromine plus a bromine attached to a carbon attached to a double bond. And we're gonna not make comments on what's broken on the other side. So for the Heck reaction, we have a palladium 2 catalyst that couples this R group to this double bond. So what we have to do is look for a double bond. And what would be attached to this double bond if we were to break it is the halogen Br, and what would be attached to the group we're coupling with would be a Br to that position. So if we look at, and I'll share my desktop with you really quick. We have just that, compound 1, we have the CH3 and the Br, and then it's going to be 1 and 6, because we need that extra carbon there. So we do 1 and 6, check my work, excuse me. Okay, so if it's not that, the other option is probably flipped, so we're going to have 3 and 4. Ugh. Okay, so you got it backwards. It happens. So actually, sorry, it's not the carbon adjacent to the vinyl, it's the vinyl itself. So actually we would make the break here. So we'd be breaking the line at the double bond, directly adjacent to the double bond, not the carbon after. Sorry, that was my mistake. So yeah, for the Heck reaction, you're looking at an unsaturated R group connected to a double bond. So in this case, the R group is the chloro group, and then it's not actually a carbon off of an alkene, it's a hydrogen off of an alkene. 54. Draw the structure for the principal organic reagent formed with the reaction 1 propanol with potassium bichromate and aqueous sulfuric acid with heat. So we've got 1 propanol, and we've got potassium dichromate with sulfuric acid and water. And this is actually known as Jones reagent. So Jones reagent actually serves 2 purposes. One, it's an indicator of alcohols. The second is that it's a oxidizing reagent. That's why it's a test for. I think for them, so I got to ask, is it 1 or 6 on the previous, or does it have to be 3 and 4? I think it has to be 3 and 4. Heck reaction is not something I'm very familiar with. So I know you have to draw a line. I know you're creating a carbon-carbon bond. For me, I forget if it's on the outlet carbon adjacent to the double bond, or if it's on the double bond itself. But I'm pretty sure it has to be 3 or 4 based on what they're saying. Anyway, all this is a strong oxidizing agent. So I'm going to go with the carboxylic acid here, but I may be remembering it wrong. That's what it is. So the big issue with Jones reagent is that it's a sledgehammer. So it's going to oxidize that alcohol down to a carboxylic acid if it can. So if this were this compound, I guess I can rewrite it. So if this were 2-propanol, it's going to oxidize until there are no more bonds between oxygen and carbon, so we would end up getting the methyl-methyl ketone in this case. So Jones reagent takes anything and slams it completely as far as the oxidation will go. If you have a primary alcohol, it'll go to carboxylic acid. If you have a secondary alcohol, it will go to ketone. If you have a tertiary, there's no adjacent hydrogen, so it doesn't do anything. If you didn't want to go all the way, so let's say you want to form the aldehyde, this is where you would work with PCC or PDC, pyridinium chlorochromide, pyridinium chlorochromate, or pyridinium dichlorochromate. So that's questions 2, 6, 23, 24, and 54. Yes, so this carboxylic acid, any primary alcohol with Jones reagent is going to form a carboxylic acid. Yeah, when I type that in, oh, I'm sorry. That's butanoic acid. It's propanoic acid. Sorry, I added an extra carbon. Yeah, I was starting to draw out the OH and then changed thought processes halfway through and treated it as a carbon by accident. But yeah, I definitely drew propanoic acid in my answer and counted it correct. You're welcome. Any more questions out there? Are we allowed to use on this next test? And the syllabus says we can, but I just want to make sure. Yes, you are free to use your notes on the next test. There's really not, like, I could sit back and say no, but it's really kind of hard based on camera angles to prove you're not. So let's just eliminate that as an issue and just say yes. You can use your notes, but that's why I give you timed exams. This way you don't have like all the time in the world to sit there and go through your notes and figure out every problem. right, question 67 on the homework for Organic 2. Hey, you're welcome. All right. Oh, this is a nice easy one. As soon as I can find my pen. There you are. All right, what is the principal organic formed from the reaction of ethylene oxide with cyanide? And so, an aqueous ethanol. So, the only question I would have about this is particularly whether or not we're going, oh, it's aqueous ethanol. Okay, never mind. I don't have any questions about the product is. So what's going to happen in this case is our cyanide is going to attack one end of the ethylene oxide. It's going to break that bond and give us this complex here with the O minus. And then this is going to extract a proton from water to give us the alcohol. So we're going to get this nitrile group on one end. It's going to bind through the carbon, so this is a weird thing about cyanide. It always reacts to the carbon, not through the nitrogen. So our carbon, it's going to be the structure of our final product. Now, that said, because this is a symmetric epoxide, it doesn't really matter which way we attack. If we have a group here, then we have to dictate if we're doing under acidic or basic conditions. So under acidic conditions versus basic conditions. For acidic, I believe we go through, the cyanide is going to go to the, so under acidic conditions, you form the carbocation. So in the carbocation, the cyanide is going to be attached to the more substituted. And under basic conditions, we don't go through the carbon cation, so this is the less substituted group. So if we had the same reaction, but we added a methyl group on one end to our epoxide, if we had it under acidic conditions, we would actually get this group, and under basic conditions, we would get this compound. Yeah, all the cyanide does is undergoes a nucleophilic attack on one of the carbons, opens up the epoxide ring. Yeah, it's actually going to make you fully draw it out. So let me draw it up on my side really quick. 1, 2. So you can't put CN in there, and I'll show you the answer as soon as I write it. So you can meet the desktop really quick. So if you look on the desktop, you actually have to draw the carbon and the nitrogen triple bond. If you put C in there, it's just not going to accept it. Fun fact, your exam is next week. Cool. We're moving right along. So yeah, for Orgo 2, your exam is next week. Explains why Elijah's asking so many questions. Let's see what it is for Organic 1. Yep, also for organic 2. Organic 2, you also have your exam next week. Right, not really seeing a lot of activity out there anymore. So, again, if you ever have questions, feel free to email them in advance. Also, here for the live stream. So, thanks for showing up, and I will see you tomorrow's Friday. Yeah, I'll see some of you tomorrow.